Hello, I'd like to welcome everybody to this webinar. It's Altecnic and Guru talking about the next generation, if you like, of intelligent HIU and intelligent control and remote reading. Just looking at who's going to be presenting today, there's going to be three of us. My name's Neil Parry. I'm head of specification at Altecnic. I have Josh Collins with us as well. He's a specifications manager, and then Casey Cole, the CEO of Guru Systems, who will talk about their side of this collaboration. Okay, Altecnic, just a little bit of background about us. We're part of the Calefi Group, who are an Italian manufacturer based just outside of Milan, with 300 million euro business and 1,300 employees, and our specialty is everything really that you find in a hydraulic system. Guru produced market-leading hardware and data analytics across heat networks, and they've been fairly fundamental through the years in obtaining information and knowledge about heat networks and then disseminating that out into the marketplace. And you know, a lot of things, a lot of facts, and a lot of performances of networks have been sort of understood really by the work that Guru have done and the data that they've been able to pull from projects. So they were the logical partner for us to tie up with to come up with this particular project. And Casey and I sat down. It was almost 2 years ago, Casey. That's shocking to say, but it was almost 2 years ago when we sat down and basically said, you know, how can we move the knowledge of heat networks and the performance of heat networks forward? And was there something we could do together, collaboration to basically bring that about? So we started discussing the Guru Integrate SATK32 project way back then, and it was literally, what are we going to do, how can we do it, and so on. And we had a number of meetings took place over the years, and then the product was actually launched just literally a month ago, and it's already been shortlisted for the ADE Innovation Award. So if you could go to the next slide, Helen, that'd be great. And I think, Casey, you would like to run through this one, I think.
Yep. So our aims here, if we look at the background of why we're doing what we're doing, one key fact is we know that heat network performance will drift over time. We know that even if you commission a heat network well and you get it set up and working on day one, it won't stay in that state. And one of the key reasons why is because you accumulate lots of little changes. The number one driver for performance drift in operation is actually technicians visiting a dwelling. So let's say they go out in response to a complaint about no heat, and they will tend to open up the HIU if they can, or get into the settings, and they will crank everything up to maximum. And maybe that complaint is resolved, but actually what's happened is you've now undone the work of the commissioning engineer. You've now turned that HIU into a problem for the wider network. In what we watched, so we remediated a number of sites in sort of 2015, 2016, and we watched over the next 3 years, and those that continued to be monitored and engaged with by the operator stayed operating well. Those that weren't watched would drift over time. It was just an example of if you're not paying attention, then it will drift. However, we're also aware that there might be problems in the dwelling that the operator can't get to. They can't get through that door. If only they could change the settings, if only they could improve the configuration of that HIU, then the problem would be addressed, but they couldn't get in there. And so when Neil and I were talking about where the big blockers were in networks being set up and then continuing to operate well, this was one of the major ones. We want to make sure that there is a way to address that configuration so that the HIU continues to behave well.
Thank you. Next slide, Helen, please. Okay, we'll just move straight on to the next slide. So I'm going to talk to you a little bit about the HIU itself first. The picture you can see is our SATK32 Indirect HIU, and I've just basically carried out 2 performance examples just to give you a feel for the performance of the plate heat exchangers that are within the unit. And the top calculation is sort of a typical multi-energy source calculation, if you like, where the energy center is putting out a temperature of around about, say, 70 degrees C. So what we can see here is that I've limited the power capacity of the HIU to 35 kilowatts. So if we look at typical CIBSE CP1 demands, that would suggest that's probably a one bathroom, or maybe even a bathroom and ensuite apartment type of output. So 35 kilowatts. And if we look at the calculation here, you can on the primary side, or the feed into the HIU, we have the 70-degree flow, and the return is extremely low at 12.7 degrees. So you've got that very big delta T, makes the system very efficient. You need a much smaller flow rate for a given output, and you can see that the flow rate there is correspondingly small at just 525 liters per hour. We drop down, this is the same HIU, but we drop down now and look at a typical low temperature heat pump led network, where the primary flow into the HIU is now 55 degrees C, so much lower. We've limited again the output to 35 kilowatts. So again, your typical one bathroom or bathroom and ensuite apartment. And you can see the return is slightly higher because we have to use a higher flow rate, because we're basically supplying the HIU with less energy effectively. So we need more to give the same output. And you can see it's 858 liters per hour in this example, but you've still got a very large delta T here between the flow and return. So still very, very efficient, and still, you know, sub 20 degrees C as a return temperature from that plate. So it gives you an idea of the performance and efficiency capability of the HIU itself. So if we can move on to the next slide, please.
Oh, lovely.
This slide really, I'm going to hand over to Josh. So Josh, if you'd like to just run us through this one.
Yeah, for sure. So if we look at Altecnic at the beginning, we learned a lot of our lessons from supplying our OEM partners in the boiler market. So if we take the lessons that we learned there, and we understand that we need an electronic HIU, because we've got an age of information and accessibility that we need to get ahead of. So that they were the key drivers when designing the HIU. But as a start, we need to make sure that we implement the right features within the HIU. So just to give you a brief overview of some of the features, we've got flow rate limitation, which limits maximum flow rate, of course. Return temperature limitation, which we're going to delve into a little bit later. We've got Modbus access to the HIU, which of course the Guru system manipulates. We've got flexibility to tailor the preheat, which I think Neil's going to touch on a little bit later on. Remote diagnostics and repair, always an important thing to have. And crucially, we're not going to touch on this later, but we've got installation and maintenance flexibility. We need to make sure that HIU has the flexibility to be installed in numerous different environments. So what we've done now is we've made it capable of having top entry, bottom entry. We've made all the components within the HIU accessible from the front, especially, you know, the predominant amount of our work inside the M25 circle. We've got spaces are paramount, so we need to make sure that we create a compact and well-insulated HIU. But yeah, to move on to the next slide, please, Helen. I think I'm on the next one as well, Neil.
Yeah.
Yeah. Okay. So a massive driver in the industry is protecting that delta T and maximising that delta T and getting all that energy from the fluid provided to the HIU. So what we've got is a feature RTL, return temperature limitation. Now, what we class at Altecnic as a safety net, a good feature which doesn't It's not a substitute for great commissioning. We still got to commission really well. We've got to make sure we maximise the energy usage within the apartment. What RTL does is, if we look at a commissioning engineer's job, what they tend to do is they commission a system with zero occupancy within the building. So what we need to do is we need to cater for the real world use of that appliance. Now, people might put sofas in front of radiators, they might put clothes on top of radiators, all affecting that tertiary delta T. Now, RTL, what it does is it autonomously looks at the return temperature back to the network, and it will do all that work in the background without the need to tailor it to yourself. So it will stop that intermittent high return temperature back onto the network, which will affect the wider network, which of course Casey touched on earlier. We don't want to be putting any negative benefits back to there. Next slide, please, Helen. Cool, thank you. So flow rate limitation, we've actually, it's becoming more and more important now on mixed heat input networks, where we might have seasonal flow temperatures to utilise the best SCOP for heat pumps. Now, what we're able to do with this is we're able to limit the maximum flow rate through the HIU. So even if the network temperature drops, what it doesn't is slam the valve open and you lose all valve authority. Now, interestingly, if we look at the slide, if you look at the last paragraph, we've got flow rate limitation gives the ability to limit the peaks and troughs through network demand, delivering a more efficient system, greater utilisation of renewable mixed energy sources, while ensuring reliability and performance are prioritised. That's key. So for our homeowner, we need to make sure they're happy with the HIU and they're getting exactly what they need, but we've also got to maintain that efficiency on the network so the cost of energy is nice and low, and try and get rid of this fuel poverty that we're seeing over the country. Windows open, for example, when we go to schemes, we don't want any of that. So flow rate limitations are really, really good feature which can be tailored in the background via Modbus to maximise that efficiency. We're not commissioning the appliance at one set point in time. We can adjust how the appliance operates through the whole year, whether it's hot outside or cool outside. And next slide, please. I'll have it back to you, Neil, on this one.
Yeah, thanks, Josh. Yeah, I just wanted to very briefly touch on HIU Keep Warm. It is a hot topic, no pun intended, and it's something that I feel is a little bit of a hangover, almost from a little bit of, say, lack of knowledge of heat networks. In this, before we were aware of the actual demands and what you see in a typical system. So before we have that data that Guru can provide, we, as an industry, tended to oversize the lateral pipe work. We tended to oversize the domestic hot water pipe work. And the problems with that is, there are lots of problems that you can get with increasing the network losses, increasing the likelihood of overheating in the building, etc., etc. But the other issue, of course, is that the larger the pipe work is to the HIU, the more volume you have. And you then have to keep that volume hot, because if you let it cool, there's way too much volume to get through the HIU to get the HIU to produce domestic hot water. So because we were oversizing, it kind of took you down a cul-de-sac where you had no choice, and you had to, at the very end, say, I need Keep Warm on, because I need to keep everything flowing round, because I've got so much inertia in the system. Everything's got to be kept really, really hot. The HIUs were often not installed in the best position in the apartment, so you had runs going into the apartment, or they were away from the takeoff point, so you had long domestic hot water runs. Lateral pipe work, you know, if you have a riser right on the side of the building, really long lateral pipe work, you've got no choice than to keep everything circulating to ensure that tenants aren't waiting a long time for domestic hot water. So that data that we've been able to pull via Guru from networks is really driven our knowledge, as I say, and a lot of that information was fed into the CIBSE CP1 document, and I've just got two little pictures there side by side, which have come directly from that document, where they're recommending, you know, shared risers basically to minimize that lateral pipe work. And if you do minimize the lateral pipe work and you also correctly size it, so you've got small diameters, you dramatically reduce losses on the network, dramatically reduce the chances of overheating in the building, but you remove your need for having a preheat with a permanent flow going all around the network to keep everything incredibly hot. If you actually couple that to a HIU that has the facility to operate its control valve non-proportionally, if I word it that way, i.e. boost its position to pull as much primary water through as it can in the first instance, to bring your hot water temperature up at a very fast rate and then drop down to the control position. If you couple all those things together, then you basically remove the need for preheat within the majority of networks. Now, the Altecnic SATK32 and 22 keep warm functionality is configurable. It's one thing I want to talk about on our later slide about the flexibility that we designed into the HIU. But just briefly here, the three standard settings on the HIU is off, so there's no preheat going through, so you're maximizing the efficiency of the network if the network is such that you can do it. If you switch it on, it's then permanently on, as you would normally see in, say, a typical mechanical HIU, where it's just on 24 hours a day. So you can set it that way if that's how you prefer it or your network requires it. And the third option is you can actually give that functionality to the tenant, excuse me, so he can switch it on or off as he wishes, but also he can actually just set it in the same way that he'll set his heating, so that the preheat can be off all through the night when he's asleep. It's off all day when he's just in the morning. It comes on with his heating, say, let's say 7 o'clock in the morning, and he gets instant hot water production when he needs it, you know, and then it's off. And so he's not wasting energy when he doesn't need it. He's only using it when he actually requires it. So a good way of optimizing energy use and minimizing the bill to the tenants. But all these options are exactly that. They're options, and they can be set or unset or configured accordingly. So give you that flexibility to match the HIU to your system. Next slide, please, Helen. So just carrying on with that flexibility, it's that, as I say, it was fundamental to the design process for the SATK32 and 22, and it is a case of configuring your HIU to your network. You know, there isn't such a thing as one size fits all. What's right for one project may not be right for the next, and it may be awful for the next one. You just don't know. So it's a case of being able to tailor the HIU to meet what you want on your network. And to give you some idea, I've just pulled some of the features that you can change and adjust here. You know, Josh mentioned about the top or bottom connections from the HIU. Absolutely, that's something which, you know, we wanted to design in. It just ensures that if a contractor's got a HIU on site, he can install it in that apartment. If he needs the connections on the top, he just turns the HIU so it's top fed, or if he wants it from the bottom, he can turn it. The same unit is underfloor heating or radiators. It's just configured in the controller, and it has its own safety thermostat and mixing and everything in there. So it's, again, same unit, nice and easy. It is configured for prepayment if that's what you want, in that it's already in there. If you want to use it or not, you can at any point. There's no wet work required to do that. It's already in. You can just switch it on or switch it off. Energy meter inside, of course, very typical, but we will install an energy meter that meets whatever specification you actually want. The keep warm, as we talked about, so I won't mention that anymore, but it can be configured. The RTL that Josh mentioned, the return temperature limitation, again, that can be configured, not only switched on or off, but what temperature do you want the HIU to try and give you back onto your network? That can be configured in 1 degree increments. The same with the flow rate limitation. We can limit that on the HIU to match the outputs that you need on that particular project. We have the ability for pasteurization. If there's a concern about potential bacterial growth in the HIU, we can automatically set up on the unit a pasteurization cycle that you know, pasteurizes the plate heat exchanger. And if you have a system where you put in a domestic hot water recirculation loop, maybe in a very large apartment, you know, a penthouse or something like that, where you've got multiple bathrooms, then that hot water recirculation loop can also be pasteurized as part of the HIU itself. And so you can use it or It's all there to be configured as you wish. And the key point really at the bottom is that all these features can all be configured remotely by the Guru hub once it's connected. So if I can have a So I just wanted to break it down. This is my my final slide before I hand over to Casey. So just wanted to break it down by discipline, really. Some of the benefits of the collaboration, the benefits of the HIU and the Guru system as a whole, so the two together. So for the consultant, you have a HIU that guarantees that his design parameters are achieved. So, you know, limiting what the HIU can take from the network, guaranteeing that his the flow rates he needs, he's calculated he needs, can be set into the HIU, so he knows categorically that what he's designed is what he's going to get once the HIU is installed. It's really crucial, I think. The HIU then he can configure to meet the requirements of his project, and as we saw in one of the earlier slides, get exceptionally low return temperatures, you know, 12 degrees up to 19 degrees, depending on your primary flow temperature going in. So really low return temperatures, so very efficient system. For the installer, he gets the remote commissioning of the HIU. He can do it from his office. He can literally log on through the Guru system and set up the HIUs all remotely, make sure they're all working correctly, all have the right parameters set, doesn't need to send people around and go into all the different apartments. Remote fault diagnosis. Once this is up and running, you can see faults on the HIU. If there is a fault, it will come up and tell you, may even tell you before the tenant actually knows about it, that there's an issue. But you can, just the same way, you can see issues on the net. Now, that can be, excuse me, you have one floor that's not operating correctly. You'll be able to see that from the data that are provided on the Guru platform. You'll be able to zero in even before you attend site exactly where the problem is and know exactly what you need to do to fix that. All, again, as I say, from your laptop on your desk. You can see bypasses left open. I think Casey will probably tell you that's quite a common thing. There are bypasses left open here and there. Might be on just ahead of the HIU. It could be on the network somewhere else, but you can see them through the software. You can see where that problem is. And you can even diagnose apartment issues. If a tenant starts to adjust his space heating valves, thinking he's doing the right thing, you can see when that's changed. You can see the difference, what's been done. You can see what effect that's having, and know that that's something you need to address. But if you do in the end have to send an engineer to site, you know straight away, before the engineer even attends, exactly what he needs to do. If he does need parts, you know he can attend with the part, so any problem is fixed first time without repeat visits to site, which is absolutely crucial, I think, for the installer. For the ESCO and client, you know, you can remotely optimize that network. You can look at all the data, you can see it, it's in a really friendly format. You know, he hasn't got to dig through piles of data to try and work out what's going on. It's graphically demonstrated to him. He can then alter the HIU, make all the changes, all done remotely, to maximize that performance and efficiency of the system. Even detect tenant issues. You know, you may see no hot water use for 3 weeks. There's something clearly wrong there in that apartment. Maybe it needs investigating. You can see things like that. You can see problems even before the tenant does, as I said. And, you know, real-time efficiency feedback. The efficiency of heat networks changes as the dynamics of the system changes, and you can see that in real time. You can see by reading the volt meters as well as the HIU meters, you can see what your losses are on the network. You can see all that kind of data all in real time, as I say. So if you could click on to the next slide, please, Helen, and I'd like to hand back over to Casey to do his part. Thank you.
Cool. Thanks, Neil. So I'm going to tell you a little bit about the core unit and then the integration between the two pieces of equipment, so between core and the SATK32. So starting with core, this is a 160 by 160 mil box that's fitted on the front of the SATK32. It's there to do two main jobs. The first job that it's doing is to pull back data from the heat meter for use in credit billing and for performance management. So you want to pull back that fine-grained data from that heat meter so that you can see exactly what's happening at the flat level, and then pull all that data into one big integrated picture so you can see the performance of the network overall. So that's the first job that it's doing, and the second job that it's doing is connecting to that SATK32 over the Modbus integration to allow it to be remotely configured. So I'll tell you a little bit more about the core. It takes a main supply, but consumes very little energy, so less than 2 watts on average. The core units are wirelessly talking to each other over an encrypted mesh network, and that's in the unlicensed band, so it's 868, great at going through walls and reinforced concrete, but you don't need to go and get a special license for it. It takes inputs from MBus, so heating and cooling meters or other utility meters, Modbus, and pulse inputs if we need to. We tend to counsel against using pulse meters or pulse output meters, but sometimes that's what we find when we're on site, so we need to deal with it. And it's also got relays built inside, and those relays they're multi-purpose. They can be used to send an enable or disable signal to the HIU, as Neil was describing before. They can be used to actuate motorized 2-port valves that are mains powered, etc. A little bit more detail on those connections. On the MBus, you can hook up to 8 utility meters, and on Modbus, I'm told we can go to 250. We haven't tried that, or I haven't seen it done. They've done it on the bench. Pulse input, we would take 1, and that the most common application that we see is when you've got AMR fitted to like a gas meter in a plant room or something that will only ever get you a pulse output. So we can happily take that. If you head to the next slide, Helen. Fantastic. So this is a screenshot taken out of the user interface on the web application that goes with Guru Integrate SATK32. And what this is showing us is that the features that Josh and Neil have been talking about, like return temperature limiting or the other settings within the HIU, are remotely configurable, so from your desk. Now that happens, it can happen pre-commissioning. It's as soon as the comms network is up and running on the site, and then it can happen during the life of the heat network and the HIU, obviously. I want to be really clear. I mean, although I work for a tech company, we would never advocate the viewpoint that tech is just going to solve it. It's just going to make it all better, right? This isn't a substitute for. I know we've got a lot of designers on the call. This is not a substitute for quality design, and this is not a substitute for solid commissioning. Those things still have to happen, but what we want to do is get the most out of this equipment. We want to get the most out of this network and achieve really high efficiencies. This is how we do that. So just pointing out a couple of things on the screen, we've got some data that is read-only, so things like serial numbers or model number, etc. What we find on sites is, although this might look trivial, it's not. Knowing what equipment has gone where is crucially important. Those schedules that are issued as part of the as-builts, if you're lucky, they're issued, and if you're even luckier, they're right. But having the ability to go back and determine what has gone where, we've found to be essential. So we've got that data here. And then the next couple of columns over are showing us the kinds of things that we can change on that HIU. It's all the things that have been described so far. The access to all those is available through this interface. There's quite a lot of power here, and that power needs to be used wisely and responsibly. So it's essential that this sits behind the access control layer, so the right people have the access to change these settings. Next one, Helen. So this is just a little example of to illustrate the importance of getting HIU settings right. So this is from a site that was being remediated at the beginning of 2020, and it's showing us a single day. It's actually 24 hours, I believe, in January of this year. And we've got the flow temperature in blue across the top, hovering just above 70 for most of the time. And we've got the return temperature in green. This is a snapshot from the plant room, not from the dwelling. So this is the view of what the plant room is seeing coming back from the network. You can see that green line sits at about 60 for 2/3 of the day, and then at 2 in the afternoon, it drops off a cliff and it goes from 60 to around 40. Now this is a 70-40 network, so you can see that when this day started, the network wasn't performing in line with its design, but when the day ended, it was. What happened during that day was that, in this case, it was the impact of one HIU on this network. So this was actually the replacement and reconfiguration of an HIU. And by having that single unit set up and performing as well as its neighbors, the flow rate through that flat plummeted, right? So one of the things that you'll find with HIUs that have not been configured correctly, or where you've had that visit by a technician who's cranked everything up to 11 that I was talking about before, your flow rates will skyrocket through that dwelling, and the high return temperatures will very quickly swamp all the neighbors. Well, when you get control of that flow rate again, this is what happens. We drop from, on this network, 60 back down to 40. And crucially then, our heat losses from our return pipe work, which is half our network, is now dropping right back down again linearly with the drop in temperature. So even that single HIU has a disproportionate effect on these networks. It's really important then that we're keeping an eye on network performance and then taking action if any units start to stray. This integration between the SATK32 and Guru Core lets us do that now without dispatching a technician potentially. You do that from your desk and you keep the network working at the least cost of intervention. That's it.
Great, thank you very much.
Thanks for that. That's a very powerful slide, Casey. Yeah, we're going through that. That's great.
Thank you, everyone. So we do have some questions that have come in, so I'm just going to run through them in the order that they come in, if that's okay. So the first one was a return temperature limit function question. The question was, do the radiators still need presettable TRVs and or thermal balancing?
Josh, you want to handle that?
Yeah. So as alluded to, Casey alluded to, and myself, RTL is not a substitute for good commissioning, good flow rate setup within a dwelling. It's not. So we would always recommend, along with Subsea, to put flow settable TRVs on all radiators. Now you've got, I mean, the gist of it is we need to maximise the amount of heat we can put into the dwelling and minimise the return temperature. So we can't have fluid travelling through the radiators at a rate of knots. So, like I say, we set up the tertiary circuit correctly, and from that point, we set the RTL a couple of degrees higher than that return temperature is meant to be, and from that point, the RTL will capture any exceeding return temperatures. For example, if we cover up radiators, or we even change a radiator without the building owner knowing. So yeah, quick answer. Absolutely, we need to be putting flow settable TRVs on radiators.
Yeah, if I could just maybe add just a little bit, the word that Josh used on his slide was safety net, and I think that's a perfect term, in that you know, you're commissioning those radiators at the commissioning stage by definition, and yes, the moment the tenant moves in, things will change, because as you know, he may put a couch of the big radiator in the living room. You know, that's going to have an effect on the return temperature. So the HIU is there. The RTL is a safety net to ensure that inefficiency that's been created now post somebody moving in is not passed on to the network. and it just protects that network from inefficiency, rather than just, you know, sort of blanket say you don't need to do anything in the apartment. Absolutely not. All the same rules apply. It just, the RTL gives you that safety net to protect the network.
Sure.
Right, thank you. And so next question is, can Guru make global changes to all HIUs on site?
Can we make global changes? The short answer is yes. So you can do batch changes to HIUs on site. Where we've started with the integration is with individual HIUs, and that's because, as Neil was saying, you may want to apply different settings in different dwellings, for example, to suit your keep warm facility. So it was essential for us that we had the granular control down to the dwelling level, applying across an entire site. For example, like a scripted configuration is very straightforward.
Right, thank you. And
one of the things I've just mentioned about that, sorry, Helen, is just to say, one of the things that really excites me here with this project is that it does future-proof your system, because if you have a 70, or maybe it's got boilers, a 70 degrees network, and at some point, you know, we all know what's happening with gas. We all know what we need to do to reduce carbon. And let's say at some point in the future, you're going to convert that plant room to heat, for instance. In doing so, your temperature will be much lower on that network. Well, to do that now, you would have to go into every single apartment. The HIU may not be suitable that's installed there. You may have to change that. Big cost changing every single HIU. But even if you don't have to change the HIU, you've got to get into the apartment. You've got to make all the manual changes into the unit to make sure that it'll now work on this lower temperature. With the Guru Integrate SATK32, you can do it all remotely. You can literally make the change, I won't say in half an hour, maybe an hour, over the network, and just actually make that change to all the HIUs, and they'll all adjust the set points to match the work that's been done in the plant room. It just gives you so much flexibility. And one of the things Casey and I have been discussing a couple of times is the ability for the HIU. This is something that we're working on at the moment, Guru are working on, is the ability for the HIU to keep a stable approach temperature so that it can match the flow temperature. So if you have a weather compensated network where you've automatically got a primary flow temperature that's changing, it's increasing or decreasing depending on outside weather conditions, well, the HIU can be set to always mimic that and follow that flow temperature. So you always keep a stable approach, say 5 degrees to pull a figure out of the air. So the HIU set points on the secondary will always change to make sure that you have that 5 degree approach temperature difference. And it just really opens up a world of ideas and things that can be done to improve networks really.
If we're future gazing, just to expand on Neil's points there, the two crucial things I think that are going to emerge in not just heat networks, but in sort of multi-vector energy systems where you're tying heat together with electricity, with transport, with waste, and so on. One of them is we're going to see the flow temperatures on heat networks need to come down and return temperatures come down, because we're going to need to accommodate lower and lower carbon sources of heat. We're going to have to adapt existing networks to that, as Neil's describing. So having this ability to remotely change settings on HIUs is a crucial step towards the ability to do that. That's on our doorstep. We're going to have to do that really soon. The other thing that's a little bit further out is that as you get these energy systems, multi-vector energy systems tied together, we will increasingly be pulling out data, analyzing it in energy management systems in the cloud, and then dispatching control signals back down to the site on an automated basis without the intervention of people. What we've done here with this integration is put in place the building blocks to allow that to happen. This is where the data flows out of the site. You expose APIs at the server level so that that data can be consumed by other systems, and then allow the control of crucial pieces of equipment on site, like the HIU, so that those algorithms can make changes in real time. That's not quite so close on the doorstep, but that is absolutely a direction of travel. So we're future-proofing for the medium and the long term here.
Absolutely.
That's great. So a bit of a follow-up question is, can Guru pinpoint the rogue HIU automatically, or does an operative have to sift through each HIU?
Say that again, Helen. I missed the middle, it cut out.
No worries. So can Guru pinpoint the rogue HIU automatically, or is this something that an operative has to go through each HIU in turn to find out where the problem is?
Okay. So we, through the use of Guru Pinpoint, so a nice use of a verb there, we do data visualization and analysis, which allows you to order your HIUs, for example, by domestic hot water return temperature or overall volume weighted average return temperature. That brings your misbehaving units directly to the top of your list. You don't have to do any sifting. You can just go straight to the ones that you need to pay attention to.
Great, thank you. And then just one more follow-up question there would be, who typically would have access to this remote information?
So it depends on the stage of the project. So we've got projects on the go now where it will be at commissioning stage, and the key stakeholders there will be the M&E subcontractor, would be Altecnic, for example, as the HIU provider, and it might be the main contractor as well. In operation, it's more likely to be locked down to the operator, who should then have the ability to extend access to the stakeholders that are appropriate at whatever moment that might be. So it might be the O&M subcontractor, for example, may also get access. It's easier at commissioning stage because there are no human beings living in the dwelling, and there are fewer data management issues. As soon as you've got somebody living in there, then you need to be all over your information security and ensuring that just the right people have access.
That's great, thank you. So we are at time now, so I'm just going to ask one more question, and it's a bit more of a general question. Do you think that there is a lack of knowledge around heat networks generally and HIUs?
It's general.
Yeah.
You did say we're at the end of time, didn't you?
It's a whole new webinar.
Yeah, there has been. I don't think there's too much doubt about that. There has been, and there's lots of reasons, for that. We, as historically, the UK have very often thought of a heat network as being a central energy source and cylinders in apartments. And cylinders, are never going to give you an efficient system that, it causes no end of trouble in terms of delta T's and so on. But the one thing they did give you is a large safety net where you had lots of water all over the place, and there we go, it's always going to work. And effectively what we're doing then is completely oversighting everything. You just got loads of water everywhere, and therefore everything's going to be fine. Well, you can imagine what comes of that in terms of the low efficiencies and so on and so forth. And to many respects, we've sort of gone, okay, we know that instantaneous HIUs give you a much more efficient system, so let's put them in. But we didn't really interrogate the primary system and the energy center enough to think, does that actually change now that we're going instantaneous rather than stored? And we tended to go with the same guidance documents, the same regulations and so on. And over the years, as various different things have come out, I mentioned CIBSE CP1, you've got BISRIA's BG62, number of other documents. We've slowly narrowed that down and slowly become more and more aware. And a lot of it, coming from data pulled from sites that Guru have done and other people, of course. But we've become more and more aware of what we actually need. And funnily enough, Modbus is actually going to give us more information. We have the ability within our HIU to know how often each individual actuator has been used and what position it's been in and how long it's been in that position. So we will slowly drill down, get more and more detail of exactly what is going on these heat networks, and hopefully that can be fed into the newer documents to come. But it's always an education process. Every day is a school day. in all counts, and we'll know more tomorrow than we know today, and that's an ongoing process, and it's never going to change.
On an engineer's level, we've seen through the door hundreds more people, engineers that we're training and giving our insight for guys on the road, look at these HIUs and to stop using Casey's analogy, turning the HIUs up to 11 just to get it working. So we are seeing a bigger uptake in guys through our premises, working on our training in our training room and pushing the right information to them. So as a consultant level, it's getting better. As a engineer level, it's definitely, we're getting a much larger uptake on that too.
I think just one other thing, Helen, that's actually a good point there, really, is that we do training free of charge. We always have done. We see education as something that should be freely given. It's not something people should have to pay for. And we can do training at our offices up in Stafford. We can do on-site training, which suits the client. And we have, I think, at count, I think it's 6 CIBSE approved CPDs, 4 of which are on heat networks, which we give out. We tend to do them online nowadays, but we're quite happy in a socially distanced meeting to conduct those CPD presentations, and we do it on a regular basis, and long may that continue.
That's great. Thank you, Casey. Do you have anything to add? Or?
The only thing I'd add is that part of our mission is transparency, particularly around the data. We've watched the performance of heat networks improve over the last 7 or 8 years as we've started to get that performance data out of sites and get it in front of the stakeholders. It has to happen. It's an essential part to a network working well. If you haven't got that visibility, you can almost guarantee that the network is not going to work well. That information is used by different people in different ways. So engineers might be using that data to design a better system next time. The operator may be using that to diagnose immediate problems and fixing them early. So there is a pool of data that needs to be made actionable for the right people. And our the day job at Guru, really the thing that unites all the projects that we work on, is trying to increase that level of transparency.
If you don't know about it, you can't manage it. As simple as that, really.
That's great. I think that's a good place to leave things, as we are a couple of minutes over time now. So thank you, everybody. And a recording of the session will be made available to all attendees. Check your emails. Thank you.
Yep. I'll just add thank you to everybody who's joined us today, and I hope it was useful. And if you have any questions at all, please feel free to contact Altecnic directly, myself, Josh, Casey, or Guru directly. We'll be more than happy to answer any questions you've got.
Absolutely.
Thank you.
Cool.
Thanks. Bye-bye.
Bye.